AP Physics, Day 5, page 120, question number 13. This is a classic vector addition problem, vector components. I would appreciate you drawing some diagrams for me. So I've labeled these T sub 1 and T sub 2, tension 1 and tension 2, with the appropriate angles. Draw the diagrams. I don't need to see all the little nitty-gritty work, but if you just write down, if you show the diagram, that's great. And then just off to the side, and you can use shortcuts here because of the 45, 45, 90, the T sub 1x will be 71 newtons. It's basically the hypotenuse divided by root 2. And the y component's the same. It's a 45, 45, 90 triangle, 71 newtons. And then T sub 2 x and T sub 2y. T sub 2y is the short leg of a 30, 60, 90, so that's 100 newtons. And then T sub 2x would be the 100 times root 3, which is 173 newtons. So that'd be great if you showed me something like that. And it's a simple addition to get the net resultant. You add the two x components up, so the resultant in the x direction will be the 71 plus 173, which is 244. 244 newtons. And the resultant in the y direction will be 171. And then you just draw your resulting vector. I can draw it like this. Well, I'll use red. So I have x is 244, and the y is 171 newtons. So the resultant, I'll draw black. The resultant here, you just Pythagorize it. And let me pause. And I guess it would be good to write down your equation there, but even then, well, let's call this r. If you have your diagram, I'm fine with just you saying, okay, it's obvious, Pythagorean theorem. You can just say r equals 298 newtons. The diagrams say a lot for me. It's showing me that you know what you're doing. You have r pointing in the right direction, and you got to figure out the direction of theta. So you're going to use inverse tangent. So once again, if you have the diagram labeled, I'll let you do the just write down the answer. But basically, it's going to be tangent of theta will be 171 over 244. So you use your inverse tangent function, and I believe you get theta equal to 35 degrees. So that's your magnitude and direction of the resulting vector when you add those two vectors together. It's almost 300 newtons because they're close to being lined up.